So this is your Unit 3 study guide key. For number 1, what causes an unstable nucleus? An unstable nucleus is caused by too many or too few neutrons. And then number 2, why do elements undergo radioactive decay? Well, radioactive decay is a result of an unstable nucleus. So they go through radioactive decay to reach stability. So they want to have a stable nucleus. They want to be a stable atom. And radioactive decay is one way to do that. So then filling in this picture with each type of radiation. This was in your notes. And remember the charges of each different type of radiation as you're doing this. So this is your radiation source right here, which means that you're going to have one beam that's going to go straight through, because there is one type of radiation that does not have any charge, so these plates would not affect it in any way. So this is going to be your gamma ray. And then you're going to have one type of radiation that is going to bend towards the positive plate, or the negative plate, excuse me, and that is going to be the radiation that is positively charged because opposites attract. So this is going to be your alpha radiation beam. And then you're going to have a third that's going to curve toward the positive plate, and notice how it curves more. We talked about that in class. The one that's going to be attracted to your positive plate is going to be your negatively charged radiation, which is beta. And then for number 4, making a chart to compare and contrast beta, gamma, and alpha. Your chart could be different. This is my suggestion. These are the things that absolutely should be included. Of course, there are more that you could add. For number 5, what happens to any element that undergoes alpha or beta decay? Well, an alpha particle is 2 protons and 2 neutrons, so if we lose that, we're going to change our atomic number, so we have a new element. Beta decay is when a neutron inside the nucleus changes into a proton and an electron, so you're going to have an additional proton changing your element. So anytime an alpha or beta decay occurs, we have a new element. And then number 6, what is an isotope? It's from last unit, so we should know this one. Atoms of the same element, because they have the same atomic number, same number of protons, with different numbers of neutrons. And if you have different numbers of neutrons, that means that they are going to have different mass. And that information is what you would use to answer number 7. For number 8, how does mass number change with each type of radiation? Well, an alpha particle is 2 protons and 2 neutrons, all of which have mass. And if an alpha particle leaves an element, that means that you're going to have 4 units of mass that are leaving. So your mass number is going to go down by 4 with alpha. For beta, we have a neutron in the nucleus that is splitting into a proton and an electron. And a neutron has a mass of 1, a proton has a mass of 1. So essentially, we are exchanging the same mass numbers for those. So nothing happens to the mass number for beta decay. Gamma is pure energy, so energy does not have mass, so nothing for that one as well. And understanding why these mass numbers do or do not change is important for your test. So keep that in mind. For number 9, identify these descriptors as being alpha, beta, or gamma. So the only one that has no mass and no charge is going to be gamma. An electron is negatively charged, and we know that beta is negatively charged. The least penetrating, so the one that cannot go through very many substances, is going to be the largest one, alpha. And then the most damaging to the human body is going to be gamma, the one that has the least amount of mass, cannot be stopped by very much. And then the one that can be stopped by skin or paper, it's going to be your heavy one, alpha again. And then the one that can be stopped by aluminum So something pretty solid is going to be beta. So this is to kind of remind you of the strength of each of these, alpha being the least powerful and gamma being the most. So that's another thing to keep in mind for your test as well. For this one, you're just completing the nuclear equations. So if we have a beta decay here, then we know that our mass number is not going to change, but our atomic number is going to go up by 1 because we've left a proton behind in our nucleus. So this is going to become a 20, and number 20 on the periodic table is calcium, so you have to make sure to change it to that new element. Here we have elements on both sides, so we need to figure out what symbol needs to go there. So we need to figure out what type of radiation this was. So our mass number didn't change, our atomic number didn't change, which means it can only be one thing, which is gamma. And then here we have our starting element. We know it's an alpha decay, so we have to put our new mass number, atomic number, and element. For an alpha decay, our mass number is going to go down by 4, so that's going to become a 2. And then our atomic number is going to go down by 2 because you've lost 2 protons. So this is going to be a 1, and number 1 on the periodic table is hydrogen. So now that I've shown you an example of each type, you should be able to go ahead and do these two. If you want to check them, just go ahead and come up and ask me in class. Then for number 11, we're supposed to use this figure to answer the questions, and it asks how many alpha particles are produced as one atom of uranium-238 decays to an atom of lead-206. So I can follow the arrows to show me the progression of this occurring. So I end with lead-206 down here. And you could go through and look at your mass numbers to see what type of radiation is happening between each arrow, or just look at the symbols. They're there already. So use what you see. If I count up all of those alpha symbols, I have my answer. 8. And then how many beta particles are produced due to this? Again, all I have to do is count. The symbols are there. 1, 2, 3, 4, 5, 6. That's all there is to it. For number 12, write an equation showing that when protactinium-229 goes through 2 alpha decays, francium-221 is formed. So the first thing, probably the hardest part of this question, because you guys have gotten really good at nuclear equations, is just writing the symbol for this. So find the element symbol, which for protactinium is Pa, and then based on all the other nuclear equations that we've already done, the mass number goes at the top, so your 229 goes there, and your atomic number goes at the bottom. So look at your periodic table, and protactinium is number 91. So this is your starting point. Then just go through 2 alpha decays, and you'll see that francium-221 is formed. So there's my first alpha decay resulting in this atom. There's my second alpha decay resulting in this atom. So using what we just did, you can go through the steps for this, where polonium-210 goes through 2 alpha decays and a beta, and then another alpha, which I went so far as to get through, there's 1 alpha, another alpha, and then the beta, and then my last step is going to be to go through another alpha decay, and when I go through alpha, I'm going to lose 4 in my mass number, which is going to leave me with 198. And then my atomic number is going to go down by 2 because I'm losing 2 protons. So this is going to be 79. And number 79 on the periodic table is gold. So then name 3 different uses for nuclear technology. There are many, many different answers for this, but you could use things like, obviously, nuclear power, so use in a nuclear power plant. You could say that it is used for atomic bombs, of course, that's a favorite. You could say that it's used for medical purposes, just so many different applications. And so as long as it makes sense, you got it. And then for number 15, the fuel used at nuclear power plants. By now, hopefully, to goodness, you know this. We've talked about it a lot. Uranium is the fuel. And then how does a nuclear power plant work? So in simple terms, this is the simple series of events that occurs within a nuclear power plant. For number 17, what is half-life and how long can they be? Well, half-life is the amount of times it takes half of the atoms in a radioactive sample to decay to a stable form. And then how long can they be? In your notes, it talked about how it could be fractions of a second all the way up to billions of years. And number 18, is the half-life of uranium an advantage or disadvantage of nuclear power? And explain. This is something that I cannot give you the answer to. We talked about uranium's half-life. If you do not know it, you can look it up. And then form your own opinion as to whether it is an advantage or a disadvantage. And as long as you can back up your claim, you will get it right. And then I told you the possible essay questions. I kind of prepared you for them in class. This is something I also cannot do for you. This is something that you need to do for yourself. So we are on the final page here. And it says the decay chain or series of uranium-238 is shown. What is the final product in the decay series? Well, if you simply follow the arrows through the progression, this is going to be your product. So lead is your product, but we can't ever just say lead. You have to say what isotope of lead it is because you're talking about radiation. Well, how do you know what isotope? Isotopes are identified by their mass number. We have talked about this many, many times. So we have to use isotope notation. So figure out the mass number of the lead, you use the chart. Mass numbers are along this side, atomic numbers are along this side. Lead is 82, which is why it's lead, and then its mass number right across here is 206. So there you have it. Lead 206 is the final product. And then using the figure, list in order each type of decay that uranium-238 goes through to become lead 206. Well, I'm going to go ahead and do it on the actual chart. So if I'm starting here and I wind up with thorium through my first decay, my mass number has gone from 238 to 234, and my atomic number has gone from 92 to 90. So that, classic, alpha decay. And my thorium changed to protactinium, so an increase in atomic number, but my mass stayed at 234, so that is a beta. And you can see the same right shift, so this has to be a beta as well. Mass number stayed the same, but atomic number increased. Then again, we have a mass number decrease, which means alpha. This is a beta, that's a beta, another alpha, there's a beta, and last is alpha. So there's your order right there. Follow your arrows, and you got it. And that is all of your Unit 3 study guide. So be sure to study and be ready for your test. Good luck.